thank you all for coming to this presentation. We're going to talk this afternoon a little bit on Teledyne Marine's leading edge sensors to support ROV and AUVs. We're also going to look at some of the systems that Teledyne Marine make and show you some of our system level developments in recent years. So Teledyne, a quick overview for those that don't know our company. Teledyne Technologies is an American company traded on the New York Stock Exchange, and we have a series of divisions that work across different areas. Instrumentation, digital imaging, aerospace and defense, and engineered systems are our four main pillars within Teledyne. From a company perspective, large company, 5 billion revenues per year, subsequent to the acquisition of Flare, another publicly traded US company, and that completed last year. So within this, we are 22% of the company looking at instrumentation solutions across different market segments. So Teledyne Marine, that you see today, we are part of that 20 or so percent of the company. In turn, our instrumentation teams make marine solutions, environmental solutions for industry, and test and measurement systems as well. The largest segment within this is Teledyne Marine. So what is Teledyne Marine? Well, if you've come to this conference for some years, as I know some of you have, you'll have seen a number of companies that had brands, strong brands in this industry, that became part of the Teledyne story following acquisition. So right back to the 60s, Teledyne was involved in seismic streamer technology. One time we also did acquisition. And bolting onto that, from about 2003, very intentionally, Teledyne has moved into this marine space, acquiring companies, building a legacy, or actually buying the legacy of many different companies. So 2003, RD Instruments became Teledyne RDA. Benthos, ODI, and Scientific joined shortly thereafter, along with DGO, Corman, Impulse, TSS. You see the list here. So the next thing was to group these together and to work together as one team, which is what Teledyne Marine is today. That one team is represented by about 1,300 employees around the globe, giving 24/7 support from 15 manufacturing facilities. But we're not just a pocket of activity as part of a large American holding company. We actually benefit from the expertise that sits across the entire company. And you might say, well, what's the defense and space part of the company got to do with what you guys develop for use underwater? But actually there are some similarities, some commonalities between some of the challenges we have in space and what we see working in deep water. The material selection, for example, the high temperatures, the high pressures. Repair is not an option. We developed the radioisotope thermoelectric nuclear generator on the rover that's currently on Mars. We also did several of the imaging sensors on that rover. And if that breaks down on Mars, the rover doesn't work anymore. And it's similar at the bottom of the ocean. If we have technology that is designed to work at 6,000 meters, it has to work. Our positioning systems have to be reliable so that a vehicle can go down, follow its route, and then come back to surface. So we also benefit from material labs. We bought the Rockwell Scientific Lab in California. It's actually our headquarters. Our CEO and chairman, Robert Morabian, he himself is a material scientist. He's passionate about that. We still do that level of first principle science. And that feeds into the connectors that we make. It feeds into our transducers. And then in turn, the instrumentation that we make benefits other platforms. What you see here is the SWIX, Swimmer Delivery Vehicle, which we make for the US Navy. And they benefit from working with Teledyne Marine. So these different companies, as they were, become brands. These different brands, we have to organize them within our portfolio. And so loosely speaking, we have these three verticals. Some of my colleagues will handle seismic and interconnect accounts. Some will sell our vehicle solutions to our clients. And I work on the instrumentation and imaging side. And that's where we can really drive a change for our partners. If we have a partner who's building a vehicle, outfitting a USV, an ROV, an AUV, we have sensors that they can use. Some of these are very large. This photo, courtesy of Helix Canyon, comes from the North Sea. And you can see a TSS 440 pipe tracker prominently displayed at the front of the vehicle here. Our own Sea Raptor AUV, but we work with many different autonomous underwater vehicles across the industry. As you walk around this room, you'll see Teledyne's brand on a number of stands, but oftentimes actually hidden inside the solution. You wouldn't know it's there. So our brand is everywhere you look, sometimes even below the hood. If you look there, you'll find Teledyne also. We also work with the tiniest ROVs and AUVs. We've been developing ever smaller solutions to allow us to build very little platforms that work with low power, low weight, low size, low voltage, and of course, low cost. We're always being driven. Can we make something a bit cheaper, a bit smaller, a bit lighter? And there are trade-offs there. So here's a typical ROV client that we might work with, being outfit with different solutions. Some of these we'll talk about in more depth this afternoon. We're going to talk about our positioning systems. We're going to talk about the pipe tracker. But we make cameras, we make lights, we make sonar technologies, we make the fiber optic gyro compasses and the Dopplers to navigate and position the vehicles, the interconnect, USBL solutions, and the pipe trackers, pipe and cable trackers, in fact. Here's our own AUV, and again, this is designed to be a best-in-class vehicle, selecting solutions from Teledyne Marine and adding value to the complete system package. So just a couple of the things that we won't talk about this afternoon. Here's our cameras and lights. So we have a range of systems that we make in Aberdeen, UK, up in Scotland. We make HD and SD solutions, increasingly IP cameras. We talked about them for many years, but now there is a rollout of IP solutions in subsea ROV systems. We also make gigabit Ethernet IP cameras using ever faster frame rates to lock out motion, to freeze motion essentially. And we draw on sensors from all over Teledyne. Teledyne makes many imaging sensors that we select for our cameras, whether it's FLIR, Point Grey, E2V, they all offer technology that is driving change in the industrial industry that can benefit subsea. Blueview, we won't talk about this either this afternoon, so I threw in a slide. We're still making Blueview. I joined Teledyne when Teledyne acquired Blueview in 2011. This product range is now made in Denmark. We've benefited from a larger pool of engineers who've taken new coating compounds to improve the arrays on this product. It's got a new nose cone with a bumper design, so we don't pass the sound anymore through a plastic boot. It gives better, clearer imagery. So it's still going strong. The M-Series Mark II, aluminium systems to 1,000 meters, titanium systems for rugged deep water applications down to 6,000 meters. From a positioning perspective, some people say, what happened to CDL? Well, CDL and TSS merged and became TSS. We took two different companies that were on a path, and that path was to move away from ring laser gyros with moving parts to solid state strapped down fog technology. That path remained and converged, and so we have the TSS togs. We had CDL togs, now we have TSS togs. It's the best of both. We have a range there, 0.5, 0.3, 0.1 degree heading, 0.01 pitch and roll. And it's not just NAHARS, it's also an inertial navigation system that has a full Kalman filter, aided by a DVL, a pressure sensor, and USBL, and there is a surface variant as well. So there on the right you can see a TSS tog system integrated with a Tasman. It's actually the Mark I Tasman. We have the Mark II on the podium over here. But we're also making very tiny DVLs, and Grant Jennings is going to talk to us this afternoon on the Pathfinder, on the Wayfinder. As people reduce the size and want to have swarms of little robots out there surveying the seabed, it has to be low size, low cost, low power, and we're answering that with a system that's also high performance. The new ultra-compact modem from Benthos, Teledyne Benthos, another example of how Teledyne is taking our technology, shrinking it down and answering the call, can we do this smaller? My colleague Jeremy is going to present to us on our hydropack solutions. This is our in-water pipe and cable tracking systems. And here you see the 440, which we saw on the Canyon ROV. The size of that compared to the 660, we've shrunk the technology down so people can use it on small inspection class, observation class vehicles. And lastly, we're not going to talk about this one either, but I should mention it. We've replaced the 7125 from Reason with the T50. So it's all the same features, pipe tracking, flex mode, multi-detect, but with a single subsea bottle instead of two, and no topside processors. All the processing is done subsea, single gigabit Ethernet link to surface, and straight into your acquisition software. So out with the old and in with the new. And the really novel thing about the T series over the 7 series and other systems that might be out there in the market is the data is exceptionally clean. You can spend a lot of time processing your data back in the office after the survey. You can save a lot of time if you get a multi-beam system that gives you cleaner data straight from the sensor. And the secret there is all in how we build these systems. Very linear, very clean data. An example here, a very complex situation, this wreck, very difficult to process out noise if you see it in there. It's bad enough if you have a school of fish there. If you add to that the complication of a noisy sensor, it exacerbates the situation. The other thing that's really special about the T50 is the auto tracker. So here the multi-beam finds the bottom itself, it tunes in, and it gives great data within the parameters it's set up. You don't need to turn the knobs and the dials. You get your settings right as a surveyor. You can focus on QCing your data. And this is increasingly important as you go out on a USV, an unmanned surface robot. There's no one there riding the boat to change the settings. The vessel needs to do it itself. So the T-Series is highly automated, and that will increase as we continue to develop our market-leading range of shallow water and ROV-based sensors. Example here of flex mode from the T50. So really, people buy into this sensor for the clean data and for the features such as the autonomy and the multi-detect. And here in the flex mode, where we can have a swath of the seabed, full swath, but we can actually steer a number of the beams to focus on the key area here, which is the pipe. We can also have that swath follow the pipe automatically using our pipe following algorithm. So that was a brief introduction to really frame the talks that follow. I hope you have time this week to chat with our team, to meet with us. We have an expansive selection of sensors, and we deal with a diverse range of markets. But there's 25 of us here this week, all with different specialties. So speak to a member of the Teledyne team, and we'll find the right person to share with you our knowledge, discuss your application, and pick up our book as well. We've written a book full of application case studies, exploring the ocean, understanding our impact. That's here. Love for you to take a copy of that home with you today. So, we're Teledyne Marine. Our passion runs deep for this industry. I hope that will shine through on the talks that come this afternoon. Thank you very much for coming and taking the time to listen this afternoon. Thank you.
Teledyne Marine. Everywhere you look.